Okay, so we're going to do practice test 3 today. There are 20 questions in this practice test, but in actual test there will be only 15 questions. Okay, so let's look at the problem. The first question is use the given function and given interval to complete these questions A and B. The function is given and we need to find out the absolute extreme values of f on the given interval. So to answer this question, make sure that you find the critical points and find the value of the function at those critical points and at the boundary point, and you compare them. The largest one will give you the absolute maximum, the smallest one gives you the absolute minimum, and by finding those information we can choose the right graph from the given option. Okay, so because this function is continuous function, and for any continuous function on closed interval it must have absolute extreme value, either at critical points or at boundary point. So this is problem 1. My pen is not working, so let me just okay. So this is the function to find out the extreme value, absolute extreme value. This is the function, find out the derivative, and by using the power rule you can find it. The derivative of this function is 6x squared minus 36x plus 30, and now we need to find out the critical points. So for finding the critical points, just equate that derivative to 0 and solve for x. There is a factor 6, and then these are the factors x minus 5 and x minus 1. So 5 and 1 are the critical points for this function. So if this function has absolute extreme values, then it must be there should be the extreme absolute value, because it's a function, continuous function on closed interval. So that should be either at critical points or at boundary point 0, 6. So what we do, we find the value of the function at boundary points and then critical points, and when I plug x equal to 0 in the given function, it gives me 0. X equal to 1 gives me 14, x equal to 5 gives me negative 50, and x equal to 6 gives me negative 36. So these are the value of the function at critical points and at boundary points. So among this value, if you look at here, this one is the largest one, so this is absolute maximum, and this one is the smallest one, so this is absolute minimum. Okay, so these are the answer. So let's write down the answer. The absolute maximum is 14 at 1, absolute minimum is negative 50 at 5, and then as we know that at 1 it's a 14, at 1 it's a 14, at 0 it's a 0. So by using those information we can find out the right graph, and this is the only graph, the B1 is the only graph which satisfy all this information. At 0 it's 0, at 1 it's a 14, at 5 it's a negative 50, and this is the only graph, so we're going to choose this one, and that's right. Let's go to next problem. Determine all the critical points. The way we did here for finding the critical points, we found the derivative and equate with 0. Exactly the same thing we need to do here. The function derivative of this function we have given is 2x minus 14 by using the power rule, and just equate this derivative with 0 and solve for x, and that will be x equals 7. This function is it's a polynomial function, so derivative is possible anywhere. So this is the only point where the derivative is 0. So this is the only critical points. So critical point means where the derivative is either 0 or derivative is not possible or undefined. So that's the only point where the derivative is 0, and everywhere the derivative is defined for this function. So that's the only critical point we have. Here we have given acceleration a, which is a double derivative of position function, and finally we want to find out the position function. So to go back, we need to find out the antiderivative or integration two times. Okay, so this is problem 3, and if we want to go back, we need to find out the integration. So we know the velocity is integration of acceleration, that's the relation, and we know the position function is integration of the velocity. So for finding the first one, plug a of t, which is given here, which is 9.8. So for finding the first one, which is v of t, velocity is 9.8, sorry, dt, because a is given, a is 9.8. So if we want to find out the velocity, we need to find out the integration of 9.8, which is actually 9.8 times t plus constant, let's say constant 1. Since we have given a particular value of the velocity at 0, so we can use that fact here for finding this constant. So what we can do, since v of 0 is -2, we can just put -2 on the left side here and t equal to 0 here. That makes 9.8 times t is 0. So that will give us constant c1. So by using this constant, now we can write down the velocity is actually 9.8 t minus 2. So that's the velocity, but that's not the end of the story. We want to find out the position function, which is again integration of that velocity. So if you find out the integration of this function, which is integration of 9.8 t minus 2 dt, by using the simple power rule, the integration would be 9.8 times t square over 2. So we are dividing this 9.8 by 2, so that will eventually be 4.9 t square minus 2t plus, let's say this is another constant c2. I just use the power rule here for the integration. And now by using the condition here, this is called initial condition. When t is 0, the position function is 0. I'm going to apply this condition here. So 0 on the left side gives us, just replace t equal to 0 here on the right side. That will be eventually give you c2 equals 0. So the meaning is the position function s of t is 4.9 t square minus 2 times t. That's our final answer, because c2, this constant, is 0. So the answer is 4.9 t square, 4.9 t square minus 2t. That's the answer. Okay, so this is the question. Answer the following question about the function whose derivative. So we have derivative. We don't know what is a function, but we know the derivative of the function is given, and we want to find out the critical points. As we did in previous problem, critical points can be found by looking at the derivative, where this derivative, the value of the derivative is 0 or undefined. So as you can see that this is defined everywhere, so no problem with that. And we are going to equate this derivative with 0 and solve for x. By doing that, we will find out two values of x, which is 0 and 3. So these are the critical points. 0 and 3 are the critical points, so that's our answer. 0, 3. Remember, simplify your answer, use a comma to separate answer as needed. Remember, always read this instruction, how they want us to put the answer in these boxes. So the second question is, on what open interval the function is increasing. uh, to find out about the function, either it's increasing or decreasing, after finding the critical points, which is at 0 and 3, now we divide this number line into three different intervals, this one, and this one. So we're going to check where this derivative is positive and negative. Wherever the derivative of the function is positive, on that interval the function is increasing. If the derivative is negative, on that interval the function is decreasing. So what we do, we are going to check, take some testing point from these intervals. So let's say you can you can just take a testing point from here. It's, let's say, -1, from here +1, from here +4. If you do that and find out the value of the derivative at -1, if you plug this x equal -1 in the given derivative here, it will be positive. Positive. I don't care about the value. It's just either it's positive or negative. Look at here. If you put x equal to -1 here, -1 times -4 is positive. So by doing the same, exactly the same thing, if you put +1 on this derivative thing, it is negative, because 1 times 1 minus 3, which is -2, is negative. And eventually on the right side, which is, let's say, 4, it will be again positive. The meaning of this is, on the interval here and then here, the function is increasing, and then on the middle interval the function is decreasing. And that comes from by looking at this the sign of the derivative. Whenever the derivative is positive, the function is increasing. Whenever the derivative is negative, the function is decreasing. Okay, so here we can see that uh, the function is increasing on the interval. So as you can see from the information we just found, from -infinity to 0, and separate the answer using comma. And what is that? From 3 to infinity, positive infinity. On this interval, the function is increasing, and the function is decreasing from 0 to 3. And finally, if the function is going from if the derivative is going from positive to negative, that means, so on this interval from -infinity to 0 to 3 to positive infinity, as you can see that the function is increasing on this interval, and then on this interval the function is decreasing. So function is going up, and after this point the function is going down, and again the function is going uh, let me just make it, the function is increasing, and after this point the function starts decreasing, and after at 3 the function starts again increasing. So just by looking this tentative graph, as you can see that here at 0 the function has local maximum value, and at 3 the function has local minimum value. So by using this fact we can answer this question. Determine the local maximum, if any. So the function has a local maximum at, as you can see that, at 0, and then function has a local minimum at 3. So that comes from just by looking the derivative of the function. Okay, let's go to next question, and exactly this is again the same as question number 4. Find critical points, find where function is increasing, where function is decreasing, and by looking the derivative thing you can find out the local max or local minimum value. So I'm going to skip this question number 5 because it's exactly the same question for the different function, definitely. So question number 5 is skip. Let's go to question number 6. We want to identify local extreme values, meaning local maximum or local minimum value. So for that, first of all, find out the critical number. Critical number means find out the derivative of the function and equate the derivative with 0 and solve for x. So this is problem 6. The function derivative, by using the power rule here, it's 4 plus 6x, and if you just equate that derivative with 0, then you will have x equal -6 over 4, no, 4 over 6, which is -2 over 3. So this is the critical number. Okay, and now we know there is just one critical number, and we want to find out where the function is increasing or where the function is where the function has a local max or local min. So we have two different kind of tests. One is a first derivative test, where you find the critical number and you check on the left side of that critical number and on the right side of the critical number what happens to that derivative. Okay, so just this is the derivative on the left side of the derivative. If you find, as you can see that it's the value would be, let's say at -1, the value would be negative, so the derivative would be negative here and the derivative would be positive here. So as you can see that it's a decreasing until -2/3, and after that the function is increasing. So it's a decreasing until -2/3, and then after that function is increasing. So here at this point you are going to find out the local minimum. Okay, so now we can answer the question we have given here. Find each local minimum. So we know the local minimum is at -2/3, so it's at -2/3, and the value of the function at -2/3. To find out that, just put x equal to -2/3 in the given function, and that will be the value would be, after calculating, it's 4/3, -4/3. So that's the local minimum. Just by looking this this first derivative, as you can see that there is just one critical number, and the only thing it's possible here, okay, it's a bounded, so it's a bounded, so it's increasing, it's a decreasing to the left, and then after that it's increasing, and it goes up to 1. So we can find out at 1 what happens at 1. At 1 the value of the function would be, uh, if you plug x equal to 1 here, let me just find out the value of the function at 1 is 4 plus 3, which is 7. So we know that we don't care about the value on the left and on the right, but we do care that the function is increasing, and then at 1 the value is 7. So at 1 the value is 7, so the function is increasing on this interval, so before that the value should be less than 7. Okay, the value should be less than 7. Okay, so at this point, as you can see that that's the final point. At this point, and after that point, the value, there is no value because the domain is bounded. So the derivative of the function at this point does not exist because of this this final point. So what we can say is this is the local maximum value. Local maximum means if you compare the value of the function at 1 to the nearest value, to the left value and to the right value, it will be the maximum. If you compare with the left value, yes, it is the maximum value, but there is no right value. That's why we can say this as a local maximum value. So there is a local maximum because of this bounded domain, and the function is increasing on this interval. So it has to be local maximum. The function has a local maximum value at 1, and that value is 7. Okay, so this is the answer. And then finally, by using that fact, the function has local maximum at 7, the function value of the function at -2/3 is -4/3, which is local minimum. We can choose the graph we have given. So this is the right graph. Look at here. At 0 the function value is 0. At -2/3 the function has local minimum value, which is negative, what is that, -4/3, and before that the function is decreasing, after that the function is increasing. That's why this is the only right graph we have given, the options we have given. Now, which of the extreme values, if any, are absolute? By looking this graph, as you can see that the only absolute minimum value is at -2/3, and for the maximum there is none, because this graph on the left side is keep growing to the left side. So the function has absolute minimum value at -4/3 at x equal to -2/3, but no absolute maximum value. Remember, this value at 1 is local maximum, not absolute maximum. Absolute maximum means it's the largest value. Problem 7, identify the inflection point. The answer is already, I already did this problem to save some time of recording, but I'm going to explain you how you can answer this question here. Okay, identify the inflection point and local maxima and minima of the graph function. Identify the open interval on which the function is differentiable and is concave up and concave down. So whenever you try to find out the information about the concave up or concave down, you need to find inflection point. Inflection point means where that function, the derivative of a second derivative of that function should be 0. Okay, where the concavity of that function changes. So this is the function we have given, x cubed over 3 minus 2x squared minus 5. We're going to take that function. So this is problem 7. So y is problem 7. Y is x cubed over 3 minus 2x squared minus 5x. Since we're talking about the inflection point, what is that? We have to find out the first derivative, we have to find out the second derivative, and then we have to equate that second derivative with 0 for finding the inflection point. So find the first derivative by using the power rule, and that will be x squared minus 4x minus 5. Find the second derivative, that will be 2x minus 4, which is 2 times x minus 4. So if you plug this value back here, x minus 4 is equal to 0. That gives you x equal to 4. So x equal to 4 is what is that? Did I do something wrong? No, it's a 2. If you factor out 2, that should be 2. So x equal to 2 is the inflection point for this particular function. So as you can see that the inflection point is at 2, and then value of the function at 2 is negative 46 over 3. So that means when you put x equal to 2 in this y, that will give you y equal negative 46 over 3. Okay, so that's how we find the inflection point. Now find each local maximum. Select the correct choice as you have given. So local maximum, if you look at the graph here, you can see that local maximum is at somewhere here. So this is the local maximum here somewhere, but we need to find out the exact point. So what we do, we just equate this first derivative with 0 and solve for x for finding the critical points, and that's how we find the local max or local min. If you do that, the derivative, first derivative, can be written as x minus 5 and x plus 1 equals 0, because 5 times 1 is negative 5, negative 5 times 1 is negative 5, negative 5 plus 1 is negative 4. So x equal to 5 and negative 1. So these are the critical points. Okay, so now we have critical points, and so by using this critical point, we can find out where the function has local maximum or local minimum value. So you have the second derivative and you have the critical point. So just find out the second derivative at 5. So that will be, if you find, that would be positive. Second derivative at 1, negative 1, that would be negative. The meaning is, by using the second derivative test, we can say that at 5 the function has local minimum, at negative 1 the function has local maximum, by using the second derivative test. That's why I can answer here the local maximum value occurs at x equal to negative 1, and the value itself is, just plug x equal to negative 1 in the given function here, just replace x by negative 1, that will give you the y is 8 over 3. By doing the same thing, as we found that local maximum, this means local minimum, because second derivative is positive. This means local maximum where? Negative 1. Local minimum where? At positive 5. And what is the value itself? It comes from the value of the function at those points. At 5 it's negative 100 over 3. At negative 1 it's 8 over 3. So these are the value, negative 100 over 3, it's coming from the value of the function. Finally, let's go back, let's go down here where this function is concave up. Concave up means where this derivative, second derivative, would be positive. So as we know, the second derivative is 0 at we already found that information. Second derivative is 0 at 2, and then on this interval to the left side, if you check the value of the second derivative on the left side, that will be negative and on the right side that will be positive. We know that second derivative is 2 times x minus 2, so we can just pick some testing point from here. Let's say 0. Then as you can see that 0 minus 2 is negative, 2 times 2 is negative, so second derivative would be negative on this interval. Second derivative would be positive. But just look, just choose some testing point. Let's say x equal to 3. That's how we find about this either second derivative is positive or negative. So as you can see here, the second derivative is negative on this interval. That means if second derivative is negative, it's concave down. If the second derivative is positive, it's concave up. So as you can see here, it's concave down. We know that up to 2, and then after that it's concave up. So that's how I answer here. On the interval 2 to infinity, the function, the graph is concave up. On the interval negative infinity to 2, the graph is concave down. So that's this 2, which is the inflection point, divides this interval. This divides this this domain where the second derivative is negative and positive. Okay, and then from where we can find out concavity. Second derivative negative means concave down on the interval negative infinity to 2, concave down, and then from 2 to infinity, because second derivative is positive, it's concave up. Okay, again, problem question number 8. We have given polynomial function. This is a quadratic function. We want to answer the question, some of the question. I already did this problem to save the time for our recording here, so I will just go over this answer. So as you know, polynomial function, for any polynomial function, the domain is all real number. Okay, to find out the symmetricity, you just have to replace x by negative x and then check. So to find out the symmetricity, let's say problem 8 here, let's say this is function f of x, which is x squared minus 10x plus 24, and we know that the domain of this function is all real number. That is the domain. And now for the symmetricity, just find out, just replace x by negative x. By doing that, you will be able to see that it is x squared minus plus 10x plus 24. And if this f of negative x is equal to the function itself, that means the function is even function, symmetric with respect to y-axis. If this is equal to negative of f of x, then function is odd function, so that is the information we can find by comparing the value of f of negative x with f of x or negative of f of x. But look at the f of negative x here, x squared plus 10x plus 24. So this is not equal to the function itself, and if you just multiply this function by negative sign, this value is still not equal to the negative f of x. The meaning of that is this function is not symmetric. The function is neither even or nor odd. So this is for even, that's for odd. But because this value is not equal to this one or this one, that's why it's a neither. Now to find out the derivative, just use the power rule. That would be 2x minus 10. Second derivative, find the derivative of the first derivative, which is 2. We know the critical point is where the derivative is 0, and then just equate this thing to 0 and solve for x. That will give you 5. And then from there you can find out since the second derivative is positive, so at those critical points the value of the function itself is minimum. So the local minimum is at 5, which is the critical point, and then value itself is coming from the value of the function when x is equal to 5 here. Just put x equal to 5 here, and that will give you negative 1. And then let's go down here. There is no local maximum value because there is only one critical point where you have local minimum, so no local maximum. And now for finding where the curve is increasing or decreasing, just check the the sign of this first derivative. The first derivative, this is problem 8. So we know the critical point, it's 5, and then the first derivative is 2 times x minus 5. If you just pick some testing point from here, let's say 0, then you see that the first derivative would be negative. And here on this interval, the first derivative would be positive. By looking this, we can say that the graph is decreasing on this interval from negative infinity to 5 and increasing from 5 to positive infinity just by looking the first derivative. So that's how we can answer this question. The curve is increasing from 5 to infinity, and decreasing from negative infinity to 5. No inflection point. To have the inflection point, the second derivative uh, has to be 0 or undefined, but the second derivative is 2 all the time, so no inflection point. And now what about the concavity? Because the second derivative uh, is always positive, the graph is always concave up. The second derivative is 2, as you can see that, so it's always positive, so the graph is concave up on the whole domain. And it makes sense because this is a quadratic function and then it's concave up. So no vertical asymptote, no horizontal asymptote, no oblique asymptotes, uh, and then because it's quadratic function, so it should be concave up, and local minimum at 5. This is the only choice which gives you all those information right. So this is what you are going to choose. Just compare the given other option as well, but this is the right choice. Finally, by looking this graph, you can see that there is no absolute maximum value. Look at the graph, no absolute maximum value, but there is an absolute minimum value at that critical point, which is at 5. The value itself is -1. So the absolute minimum value is -1, which occurs at x equal to 5. Okay, problem 9. This is exactly the same problem like we did in problem 8. The same kind of questions, you have to do exactly the same thing. So I'm going to skip problem 9 and let's go to problem 10. So what is 10? It's a word problem, and I already did this problem one more time, but I'm going to explain you how you can do it. A rectangular plot of farmland will be bounded on one side by a river and other 3 sides by a single strand electric fence. So this is problem 10. There is a rectangular farmland, 3 sides bounded by electric fence, and one side you don't have to bound it because there is a river. Okay, there is a river. And now we have given 800 meter of wire. We want to enclose the maximum, the largest farmland by using this 800 meters. So how do we do that? So first of all, because the farmland is a rectangular, so we can say that, let's say the one side of the farmland is x length, so that means the opposite side would be always equal, and then other side is y. We want to find out we want to bound the maximum area. So just by looking this rectangle, we can say that area can be found by using x times y. And now we need to find the relation between x and y. So as you can see in the problem, it says total wire is given 800 meter, which will be used to fence this side, and this side. So the meaning is, if you add x, y, and x, that's the length of these 3 sides, that has to be 800 meter. So that gives us the relation between x and y. So if you add all 3 sides of the rectangle, that should be 800. So that gives you 2x plus y equal 800, and y equal 800 minus 2x. By doing that, what happens is now you can express this area of rectangle as x times y, which is y is 800 minus 2x. By doing that, you can see that area is the function of x, which is 800x minus 2x squared. So now we can find out the maximum value of this function by using the first derivative test or second derivative test. We can use the derivative test here because the function is function of one variable. Make sense? So find out the derivative of this function, find out the critical points, and find out the second derivative at those critical points. Wherever that second derivative is negative, that point gives you the maximum value of that function. So if you equate this first derivative with 0 and solve for x, the x would be 200. So just equate this thing to 0 and then divide 800 by 4, that will be 200. So now if you find out the second derivative from here, you know that the second derivative is negative 4. It's always negative. So that means the meaning of that is second derivative at 200 is also negative. So the meaning is the area, by using the second derivative test, we can say that area is maximum at x equal to 200. So but here, to answer the question, we need to find out the y as well. So the what is y? So if you go back to find out the relation between x and y is 800 minus 2x, so which is 800 minus 2 times x, which is 200, which is eventually 400. So now we have area, which is 200 times 400. That's why it's a 800. So it's 80,000. That's the area. And the shorter side is 200 meter, and then longer side is 400 meter. Okay. Okay, this is to understand this question or this problem. The one way I did understand this the idea behind this problem is I just you know took one paper, and then I just cut these pieces, these shaded pieces, and then if I fold it, it will give me a box, uh, covered box. So if you really want to visualize this problem, just take a piece of paper and just set these regions and cut them and then try to fold them, then you will be able to see a covered box. Okay, so in this particular problem, we have to create a covered box by using a rectangular cardboard, which is 5 inch by 8 inch, right? So this is problem 11. So there is a rectangular cardboard 5 inch by 8 inch, 5 inch by 8 inch. Okay, so let's say this side is 5 inch, this side is 8 inch, and the way we design the covered box is by cutting this shaded portion. So here in this particular problem, as you can see that uh, right, we are going to cut this part, which is of length x, and then this part, which is again x, this part, which is again x, this part, which is again x, and this part, which is y, because this is y. Okay, so it has to be y. So we're cutting x, and y from this side, and x from this side. So we know that the length of this side is 8 inch. So eventually we know whenever we create the box, this side is it's given, it's as a g. Whenever we create the box, the volume of the box, maximum volume of the box would be x times y times g. So that's the volume of a covered box. If you just create a box, there should be 3 different dimensions, which is x times y times z. Think about a box, after creating a box here, after folding it, this is the type of box you are going to see. The one side would be x, another side would be y, and another side would be z. So the volume of this box is x times y times z. So we want to find out the maximum volume. So the only way we know how to solve this kind of problem is by finding the derivative by using the second derivative test. But for that, for us, the only function we can use is a function of one variable. But here we have given three variables x, y, and z. So what we do, we try to convert the rest of the two variable into the one variable, the way we did in previous problem. Like here, initially the area was function of two variable x and y, but we created the relation between x and y and we changed y into x. So eventually a was the function of x. So we are going to do the same thing here. We try to find the relation between x and y and g and x, and then change this y and g in terms of x. So the only relation we can find is the cardboard we have given is 5 inch by 8 inch. So this side is 8 inch, but after cutting this side, as you can see that it will be so the relation is, as you can see that uh, this is x, this is y, this is x, and this is y. All together they give you 8 inch. This is x, this is z, and this is x. All together, if you add this length here, that will give you 5 inch. So what I can say is, if I add this side, which is x plus z, that will be 5 inch. And if I add this side, which is x plus y equal 8 inch. So now from this here, I can write down z equal 5 minus 2x. From here, 2y equal 8 minus 2x, and if I divide both sides by 2, y equal 4 minus x. So you see that that's the relation between x and g and y and x. By using this relation, now I can write down the volume as x times y, which is 4 minus x, times z, which is 5 minus 2x. Now the volume is the function of x. So if I just distribute this thing, this is what I'm going to get, 2x cubed. And you can do that on paper step by step. Just FOIL it, finally distribute x, and then this is what you are going to get. Okay, so now we know that volume is the function of x, and we want to find out where this volume would be maximum. For that, we're going to use the second derivative test. So find out the first derivative, which will be 6x squared minus 26x plus 20. Find out the second derivative, which will be 12x minus 26. So now find out the critical points. So just equate the first derivative with 0. If you do that, if you equate the first derivative with 0, then let me just okay, yes, first derivative equal 0. If you do that, that means we have what is the first derivative? Yes, it's a 6x squared minus 26x plus 20 equals 0, right? Yes. So now if you try to solve this one, here you are going to get two different solutions. One is 1, another one is 10 over 3. These are the two solutions. Okay, and now if you check the second derivative at 1, that will be negative, and the second derivative at 10 over 3, that will be positive. So the meaning is second derivative is negative at 1. At 1 is a critical point. Okay, so we can say that the volume would be maximum when x is 1. Volume is the maximum volume is maximum when x equal to 1. So when x equal to 1, what is the y? Just put the relation between x and y is given here. Y is 4 minus x, so that should be 3. 4 minus x, that should be 3. And g equal 5 minus 2x, we should be 5 minus 2, which is again 3. So the volume would be maximum when x is 1, y is 3, and g is 3. 1, 3, and 3. The idea is you have to, you know, express this function which you want to make a maximum or minimum as a function of one variable only, and for that you have to change other variable into that variable by using the given information. Okay, this is another application problem. Again, we're going to do the same thing. We are trying to create a storage set, and that will look like this. Let's say 12. Okay, a storage set is to be built in the shape of a box with a square base. It is to have a volume of 225 cubic feet. The concrete for the base costs $6 per square feet. The material for the roof costs $3 per square foot, and then material for the sides costs $2.5 per square foot. Find the dimension of the most economical set. So the meaning is you want to minimize the cost here. So we have to create cost function. So but before that, think about this. This is what you are trying to create. A cubical box with a square base. So this is the square base. This is not exactly look like a square. So this is the square base. And you want to create a, think about a room, you know, a room with a square base. So this is the square base. Okay, so our this base is a square. So think of, let's say this is the x, the length of this square is x, and then height is, let's say, y. Height of the this box, this room is y. So now as you can see that, think about the, you know, so the base is x, then height is y. Okay, so now this is the base. This is the base. Base is the square base and the height is y. So we want to minimize the cost. So to create this storage, there are 6 sides as you can see. One is the, you know, the bottom part, base. Another one is the roof, which is also x times x, and all, you know, 4 walls. The 4 walls, they can they can be calculated by multiplying x and y. So x times y, x times y, and x times y. So there are 6 sides, base, roof, and 4 walls. So the base area of the base is x times x, which is x squared. Area of the roof is x times x, which is x squared. And area of all those 4 sides is x times y. So there are 4 walls. So these are the area for all these 6 sides. So now if you go here and then see the relation between the x and y, as you can see that the volume should be 225. So the volume is 225. We know the volume means x times y, because one side is x, another side is x, and another side is y. So that gives us the relation between x and y. So y can be written as 225 over x squared. Okay, so the base area is x squared, the roof area is x squared, the wall, you know, this 4 wall area is 4 times x times 225 over x squared, which is eventually, what is that, 900 divided by x. So that's the area for the 4 walls. So now the cost can be calculated by multiplying this area of the base by $6. That's what we have given. $6 for the base, $3 for the roof, and then $2.5 for the 4 walls. So the area of the 4 walls is 900 divided by x. So if you multiply 2.5 times, what is that, 900 divided by x, that will be the cost for the 4 walls. So this cost is the cost, this cost function is the function of x. That's how we create it now. So if you add 6 and 9, that will be 9x squared, and then this is what is that, if you multiply 9 times 2.5, which is 2250 divided by x. So this is a cost function. We want to find out when this cost function is minimum. So once again, you need to find out the first derivative. You need to find out the critical point. For finding the first derivative, just use a power rule. You need to find out the second derivative, and that is 4500 divided by x cubed. Since this x is the length of length of that storage, that x has to be always positive. Because x is positive, the second derivative is always positive for any x. The meaning is, whatever critical points you are going to find out, we're going to find out here. At that critical point, the second derivative is positive, meaning at that critical point, the cost function would be minimum. So let's find out the critical point. For finding the critical point, we need to just equate this first derivative with 0 and solve for x. So as you can see that the first derivative is 18x cubed, and what is that? No, the first derivative is, if you go up here, it's 18x minus 2250 over x squared. 18x minus 2250 over x squared. If you change the side here, you can write it down this as 18x equal 22 over 50, and if you multiply both sides by x cubed, it will be 18x cubed equal 2250, and then if you just divide both sides by 18, x cubed would be 125 and x would be 5. So the second derivative at 5 is positive. Because of that, we can say that cost function is c of x is minimum when x is 5, when the x is 5. So we know that the length of one side of the base is 5 feet. It has to be 5 feet. And then height, what is the height? Height is y. Y is, as you can see from here, the relation between x and y. Y is 225 over x squared. So it's a 225 over x squared, which is 225 over 25. If you divide 225 by 25, that will be 9. So the answer is 9. Okay, 5 and 9. That gives you the minimum cost. This is just a general antiderivative. Use the power rule for the general antiderivative. That would be just using the general power rule. This is question 13. So 12x plus 5 dx. So it would be 12 times x squared over 2 plus 5x plus c. Don't forget about c. And simplify this 12 divided by 2, which is 6x squared. 6x squared plus 5x plus c. That's the general antiderivative. Okay, using rectangles whose height is given by the value of the function at the midpoint of the rectangle base, the midpoint rule, estimate the area under the graph of the following function using the 2 then 4 rectangles. So remember, this is the the Riemann sum approach. We try to divide the interval into different sub-interval, and then from there we can create rectangles using left endpoint, midpoint, and right endpoint. In this particular problem, we are asked to use the midpoint. Okay, so first of all, let's say we know this is the this problem is 14. If you try to plot the graph of this function 18 minus x squared, this is the graph you are going to get, the symmetric graph from -9 to +9, right? And now, as you can see that here we want to divide this -9 to +9 using the 2 then 4 rectangles. So first of all, we want to use the 2 rectangle only. So 2 rectangle means we want to divide this interval -9 to +9 into 2 rectangles. So that will be at 0. But by using the midpoint. Midpoint means there are This two subinterval -9 to 0 is one, 0 to 9 is another one, and we want to use the midpoint. So midpoint of those subintervals. So how do you do that? I'm going to use different color here. Uh, okay, so look at here. So the midpoint of -9 to 0 is 4.5, 4.5, and then finding the value of the function at 4.5. That's the value of the function. We know the function is 81 minus x squared. So find the value of the function at 4.5, negative 4.5. That is, if I calculate that thing, what is that? That is 81 minus 4.5, right? Okay, so just calculate that. It is 81 minus 4.5 whole square, and that is the height we're going to use to create a rectangle there. So 4.5 whole square, and it's minus by from 81, that's 60.75, 60.75. So this is the height, which is 60.75. We are going to create a rectangle from here. Okay, so we are going to use this rectangle on this side, and another side, this is again 4.5. So make sure that, where's that, it has to be at the same point. So 4.5 has to be here, because on the left side and right side they are on the equidistant, and because it's a symmetric graph, it has to be the same value. So from here to here we're going to create another, but the height would be same, the value of the function at negative 4.5 and then positive 4.5, that would be the same number. So we just have to find out the area of this part and this part, which is basically the same area. So what is that? So that would be the area is the width, which is 9 times the height, which is 60.75. 9 times 60.75. Okay, so basically by using these two rectangles, the area would be 2 times, I'm just saying 2 because the area of this part and area of this part would be same. 2 times 9 is the width, height, which is the value of the function at 4.5. At 4.5 or negative 4.5, that will be the same value. So it's a 2 times 9 times 60.75. So 60.75. Okay, 2 times 9 times 60 times 75. So eventually that will be 1093.5. 1093.5. So that's the answer for the first part, 1093.5. Okay, and now we can do the same thing, but we can, instead of just creating where is that, instead of just creating 2 rectangles, we need to create 4 rectangles this time. Look at here, using the 2 and then 4 rectangles. 4 rectangles means, we want to divide this interval -9 to +9 into 4 different subinterval. So if you do that, that will be, this is 2 and then this is 4. So that would be what is that? So that would be negative 4.5, positive 4.5, 0. So these are the subinterval we would like to use. But to create the rectangles, we have to use the midpoint of this subinterval. So when we try to create the rectangles, we have to use the midpoints. So the way we did before, using the 2 rectangles, now we are using the 4 rectangles, and again we need to create the the rectangles using the midpoint. So this is the midpoint. And this is how we are going to create rectangles. Once again, the area of this part would be equal to the area of this part. Area of this part would be equal to the area of this part. So if you try to find out the area of all these four parts, eventually that will be, the width, which is 4.5, the width of each subinterval, which is 4.5, times the height. Height is the function value at, the midpoint. What is the midpoint of -9 and -4.5? It's a negative 6.75. This is negative 2.25. This is positive 2.25, and this is a positive 6.75. So the area would be the width, which is always same, which is 4.5, times the height. Height is coming from, for the first one, it's coming from the value of the function at negative 6.75, the value of the function at negative 2.25, the value of the function at positive 2.25, the value of the function at positive 6.75. So height times width gives you the area of each of these rectangles. Just plug the value of this function, and remember, when you try to find the value of the function at negative 6.75 or positive 6.75, they will be the same thing. They will give you the same answer, because it's the function itself is 81 minus x squared. So no matter what x you pick, either positive or negative, that will be the same answer. So do exactly the same thing we did before while using the while using the two rectangles only. We found the value of the function at those midpoints. So if you do that here, the value of the function at 6.75 or the value of the function at negative 6.75, both of them will give you the same answer, and that is just calculate that 81 minus 6.75 whole square. And similarly, uh, the value of the function at 2.25 or negative 2.25, that will be again same thing. So find that, put this value back here, and then eventually do the calculation, and that will give you this. So this can be written as 4.5 times 2. I'm just saying 2 because this value and this value, you will have the same value, so you can add them and you can make it 2. The value of the function at 6.75, the value of the function at 2.25. So it's a 9 times the value of the function at here and then value of the function at here. So eventually this value is 9 times the value of the function. This one is 81 minus 6.75 whole square, and this one is also 81 minus 2.25 whole square. Okay, so if you add this 81 and 81, it's 162, and this square of this is 5.0625. Square of this is, what is that? No, the square of this 2.25 is square of 6.75 is, it's a 45.5625. I'm using my calculator here. Square of 2.25 is 5.0625. So now if I subtract this, if I do this calculation here, so negative 45.5625 negative 5.0625 and then positive 162 and then multiply it by 9, that will be 1002.375. That's the area we can calculate by using 4 rectangles. So that is approximately 1002 0.375, and that's perfect. This very similar kind of problem you need to do in next problem here. Here is the function x squared minus 1, and you want to partition this function using the left endpoint, right endpoint, and midpoint. So by using the very similar approach, here we are using the midpoint, but sometimes you also have to use the left endpoint, right endpoint, and then midpoint. Midpoint we already see. For the left endpoint, let's say this is the problem we are doing, which is x squared minus 1 from 0 to, this is problem number 15. So x squared minus 1 is what is that? It's from 0 to 2. So at 0 the value is -1, and 2 the value is, okay, value is +1. So we want to find out, graph the function. This is the function, and we want to divide this interval 0 to 2 into how many subinterval? 4 subintervals. So if you try to divide this 0 to 2 into 4 subintervals, so that would be 0 to 0.5. I'm just going to do one of them, okay, and 1.5. These are the 4 subinterval. So now to create your rectangles, first of all we're going to use what is that, left endpoint. So on this interval the left endpoint is 0. So to create the rectangle you use this height for the first one. For 0.5 you use this height. For 0 there is nothing you can do, the height is just 0. And for 1.5 this is the height. So these are the 3 rectangles you are going to get if you use the left endpoint. So this is the only option you can use. You can have all these options, they will not satisfy this situation, so this is the option you can choose. For the second time, instead of using the left endpoint, we're using the right endpoint. So if you use the right endpoint, so what you are going to get, this is what you are going to get, okay, and then finally the midpoint is this one. So this is very simple idea we use in problem 14 as well. So just do exactly the same as for the midpoint, same as the problem 14, okay, and you will be fine. Use a definite integral to find the area of the region between curve y equal 18x on the interval 0 to b. Okay, I need some pages here. So let's find out, okay, here. We want to find out, we use a definite integral to find out the area between the curve. So this is problem 16. We know this is a linear function, which is y equal 18x is like this, and we want to find out the area between the curve from 0 to b. We don't know what is b, but b is greater than 0, so somewhere here we want to find out this area. We can find this area by integrating the function 18x from 0 to b, from 0 to b. So we can use the fundamental theorem for finding the integration, the just power rule, and this is a definite integral. So the integration of 18x is 18x squared divided by 2, and we have to put x equal b and x equal to 0 here. So that would be 9 times b squared minus 9 times 0 squared, which is eventually 9b squared. So that's the area. Find the total area of the region between the x-axis and the graph. So if you try to plot the graph of this function, there are 2 parts you are going to see. Let me just show you. This is problem 17. Problem 17. If you try to plot the graph, because this function y is x cubed minus 6x squared plus 8x. If you factor out x, it's x squared minus 6x plus 8, which is eventually x minus 4x minus 2. That tells you where this function is 0 and where this function is not 0. So at 0 it's a 0, at 2 it's 0, and at 4 it's 0. So when you try to plot the graph of the function would look like this. Okay, so if we want to find out the area, we know we can use the integration for finding the area of this part a1. But if you find the area, if you use the integration from 2 to 4, that integration gives you the negative of the area. So this a2 would be negative. So what do you have to do? The total area is a1 plus absolute value of a2. a2 means the integration from 2 to 4. So a1 means it's the integration of the function from 0 to 2, which is x cubed minus 6x squared plus 8x. Find out the integration of this part from 0 to 2, and that will be, I'm going to skip this general power rule thing and then definite integral technique which we are doing so many times. Just find the integration, use the general power rule, and then plug x equal to 2 minus x equal to 0 here. That will be 4. That's what you're going to get. For a2, if you do exactly the same thing, the value would be negative 4. But the area is a1 plus absolute value of a2, which is 4, plus absolute value of negative 4 is positive 4, so it's eventually positive 8. Okay, so that is positive 8. Total area is positive 8. Okay, solve the initial value problem. Just use antiderivative. This is exactly the one problem we did before, the initial value problem. What is that? From acceleration we found velocity, from velocity we found the distance function. We did somewhere here. Okay, yes, so that's problem, what is that? Problem number 3. It's exactly the same problem like 3, but even lesser than problem 3. So you just have to find out one-time integration, and to find out the constant you just put t equal to 1 there, and then the constant, solve for the constant, and eventually write down your answer as a using that constant. But to find the integration you have to use the substitution rule. So okay, here's the thing. So problem 18, you want to find out the s of t, which is integration of that function, which is 20t 5t square minus 3 cube dt. And then to find out this integration you have to use the substitution. So substitute u equal 5t square minus 3, so du would be 10t dt. But here you have 20, so just multiply both sides by 2. So 2 times du equal 20t dt. So now this s of t is actually you can replace 20t dt by 2 du, and then this one 5t square minus 3 by u q du. So now find the integration, which is 2 times u to the power 4 over 4 plus constant, which is half, but u means 5t square minus 3 to the power 4 plus constant. So this is your s of t, but you don't want your answer as in term of constant, so you have to use this condition, s of 1 equal 13. So when you replace this t by 1, that will be 13. So same thing happens here, half 5 times 1 minus 3 to the power 4. So if you just simplify this, so that will be half 2 to the power 4 plus c, which is 2 cube plus c. So the constant would be 13 minus 8, which is 5. So the constant would be 5. So eventually the answer s of t is this one plus 5. Half 5t square minus 3 to the power 4 plus 5. That's the answer. Okay, to find out the answer for this one, the area for the the right part, just the integration from 0 to 5. But to find out the area to the left part, you can find out the integration, but integration gives you the negative of the area, so you have to make it positive. But before doing that, if you look at this function here very carefully, the function we are using here, what is that? It's a problem 19. Let's say the function f of x is x times square root of 25 minus x squared. If you find f of negative x, that is 25 minus x squared. So this is actually negative of f of x. The meaning is this function is odd function. Okay, this function is odd function. So the area of this part would be very similar to if you find the integration of this part, the integration of this part would be negative of the integration of this part. So to find out the area, what do? You find the integration of this part and then just double it, because this is the same as the integration of this one but negative. We don't want negative for the area. You understand what I'm saying? Because this is the odd function. The integration on this side would be opposite of the integration on this side, but the value wise they would be same. The direction wise they would be opposite, but we don't need the direction for the area. It has to be, both has to be positive. So when you try to find out the integration of this function from 0 to 5 x times square root of 25 minus x squared, so from 0 to 5, if you multiply that by 2, that will give you the area for the both part. Okay, since if you integrate from negative 5 to 0, it will be negative, so you are just making it positive. Okay, and eventually if you try to find out the area, if you try to find this integration, the integration would be, you have to use the substitution rule the way we did in problem 18. After using that, the integration would be for this one would be 250 divided by 3. 250 divided by 3. Use the substitution rule like we did in problem 18. Again, use the substitution rule here. Say u equal ln x, and then you can find the integration. Let me just give you, so just say u equal ln of x du equal 1 over x dx, and from here you can find out the integration. First of all, just do the indefinite integration. This problem can be changed to ln means u to the power 4, 1 over x dx is du. So this is eventually u to the power 5 over 5 plus some constant, but we don't have to write down that constant because eventually we want to find out the integration of definite integral. So u means it's ln x to the power 5 over 5. Okay, so now if you want to find out the integration from 1 to 243 of this function we have given, then this is the integration. Just put x equal to 1 and 243. That will be ln 243 to the power 5 over 5 minus ln of 1 is 0, so you don't have to write down that. Okay, did I do something wrong here? Yes, no? Oh, I missed 625 here. Here is a 625. So here is a 625. 625. Here is a 625. So I have to bring that 625 here as well. So I have to multiply this 5 by 625 because I forgot about that 625 here. So eventually multiply this by 625, and that will be 3125. So the answer would be, it's a ln, what is that, 243 to the power 5 divided by 3125, which is 5 times 3, 625. Okay, so that's our practice exam 3.